Hello, my name is Austin. Welcome to my presentation or demonstration. I chose Optuna, which deals with tuning hyperparameters and optimizing machine learning models. So let's just jump in and we'll just see that everything is working well. So I'm going to select a new kernel so you know that I'm running this code for the first time and it's working. For packages, nothing too crazy. We're using TensorFlow, obviously Optuna, and a few things from Keras and sklearn. Um, for data, we're using Yahoo Finance, so we'll need to import that, and we'll just call on that API, and we can use whatever symbol we like. I'm using Tesla. Um, and in this function, we'll get the historical data, and then we'll also engineer a few features to train on. So I think we're using relative volume, Bollinger signal, as well as volatility. And then here we'll just see, there we go, that we're getting the data frame as expected. And we'll just see the correlation just for fun. Volatility stands out, volume stands out, not so much Bollinger signal, but yeah, we'll plot as well, and we'll see that Tesla had a pretty amazing bull run from early 2020 to late 2023. And in this cell, we're creating data sets using Keras time series data set from array. Pretty standard here, split. And the way this function works is you can actually pass in a list of the feature columns you want. So if you wanted to increase or decrease that however you wanted, you could do that. So we'll go ahead and run that. Excuse me. Here we are creating a function that will is basically the loss we're trying to minimize, and we're getting into building our model in this function. So the way this works is we have different parameters for this function that builds a model. And Optuna will actually call on this function and pass through different combinations of parameters. So you can see we have a few different layers here, pretty standard stuff. And then we have a little bit of logic here to return certain optimizers based on the suggestions. Yeah, so that's how we start building the model. And then here's how we actually start implementing Optuna in this objective function. So we attach these different suggestions, and so you can expand these, you can not use all of these, but in this project, in this case study, using optimizer name, LSTM units, dropout rate, learning rate, epochs, and batch size. And we create a few different suggestions, and it'll go through and try different combinations of all of these. So obviously you can imagine if you want to do this without Optuna, it would take an enormous amount of time. The great thing about Optuna is that it doesn't actually fully build and test out each model before moving on to the next. It will take a sample of intermediate result and figure out, okay, this is doing this, well, let's try this next. And you'll see here that we have these suggestions, and these are being used in our build LSTM model. And then when we fit the model, we also have different suggestions being inputted here and returning a loss. So the way this program works is we're not actually returning the model itself. We're basically just studying how it's doing each different combination. And yeah, that's basically where the callback comes in. Is we're just printing out what's happening in each trial, what parameters we're using, what's the loss, and that way we can keep track through the printouts, which you see right here. Um, and so, yeah, it's a lot of information, but you're getting the mean absolute percentage error here. I think you also should be seeing the loss. And then if we go down to the bottom, watch us see this last instance. The best was in trial 19. It's the last one since we're starting at 0. And we can look and we'll see, okay, we used stochastic gradient descent with 50 units, only 5 epochs, and all these different parameters to come up with the most optimal model. Excuse me. And our study object will have best trial, and best trial has all these different parameters, so we can rebuild the most optimal model with our using our build LSTM model function. And that's what we do here. We just have to call the best trials parameters LSTM units, and it will, grab this last trials parameters, the LSTM units from it, and it'll plug it in. So we're actually not going to run this for this demonstration. I'll come back up here and run it just to show you that it's working. But this takes about 30 minutes to run, and I don't want to waste time too much. So instead, I will load these different models, and we'll just see. This is actually a different model than the one that we found here, the stochastic gradient descent model. But nonetheless, we loaded an Optuna model and a non-Optuna model, and the reason I'm doing the non-Optuna model is just to serve as a baseline for comparison. And we'll get a little bit of information here. Summary, the loss that we're tracking, and the same the non-Optuna. So we'll before I print out some metrics, we'll just track actual versus predicted. And let's first start out with plotting that. You'll see non-Optuna was pretty wild. Remember, we're targeting daily returns. Optuna looks much closer to that blue line than non-Optuna. And here we'll just have the Optuna and the true returns. And see, it's not doing a terrible job. And we'll create a backtesting data frame here. And we'll just plug in predicted returns versus actual returns to start off with. And then here's the logic for backtesting. Basically, if the absolute value is above 0.01, we will buy or sell. But if it's below 0.01, if we think there's only be a 1% change or less, the next day we'll just hold. We'll have a signal of 0. We're not going to enter into position. But if it's above 0.01, we'll enter a position at open and then close it out at close. And so you see that's what this logic is doing here, and that's the actual return. And so if it's above 0.1, we'll append that to opt returns, and we'll show that we have a signal of 1. If it's below negative 0.01, we'll actually short the stock market that day, and we'll just take the negative of the actual return. And we'll do the same thing for non-Optuna. And so you'll see here the results. Actually have some printout statements here. So if we had the hold strategy, we would have made about $15. Optuna signal trading strategy made about $70, and that's about $55 more using signal trading. Just to show you, it doesn't matter how worse performing the model was. The baseline signal trading actually made $15 more in these two comparisons. And I ran a few different models. Some of them I just haven't saved, and I've seen a lot worse performance from the Optuna model and a lot better performance from the Optuna model. So, it's probably not something you want to put your money on, but just for fun, we're tracking that. And here we have some metrics on loss. And it'll say, oh, okay, yeah, Optuna does a lot better than non-Optuna models as far as loss. Okay, that's my presentation, my demonstration. Let me actually go back up here. We'll just show you that, yeah, this will run. It's working all right. Might take a minute to get that first printout statement. There we go. Alright, so trial 0 had such and such loss with these parameters. That's what we want to see. Okay, I think that will do it for me. Thanks so much for the class. I had a great time, and looking forward to presenting this in class. Thank you.